In this lesson, we're looking at vector equations of a sphere. So we'll start off by stating a Cartesian equation. The Cartesian equation of a sphere is an extension on the circle, so it's x take h all squared, y take k all squared, and then z take l all squared is equal to r squared. So obviously the center will be given in 3 dimensions by h, k, and l, and the radius will be given by r. Now, if we extend that into a vector equation, so vector equation of a sphere, it's defined by being the magnitude of the difference between vector r and the center of the circle is equal to a, where a is the radius of the sphere, c is the center of the sphere. Obviously then OC is a vector from the origin to the center of the sphere, and point P lies on the surface of the sphere if and only if the position vector r satisfies the above condition. So essentially what we're saying is that a vector representing a point on the surface of the sphere P, track vector from the origin to the center, its magnitude will be equal to the radius of that sphere. Okay, so now utilizing this, we'll look at a couple of examples. In this example, we're looking at a sphere with a center of 1, -2, 3, and a radius of 6, and we're trying to find the Cartesian and vector equations of the sphere. Okay, so if we start with the Cartesian equation, we should be able to note straight away that h is equal to 1, k is equal to -2, and l is equal to 3. That end, the radius, is equal to 6. So as we're looking at x take h squared, y take k squared, and z take l squared is equal to r squared, then that's nice and simple then. It is x take 1 all squared, y plus 2 all squared, and z take 3 all squared, and that will be equal to 36. All right, that's it. That's our Cartesian equation. The vector equation is just as simple. We should be able to say that OC is equal to I take 2j plus 3k. A will be equal to 6. And as a vector equation is R subtract OC, magnitude of, is equal to A, then we end up with R subtract I take 2j plus 3k is equal to 6. And that's it. That's the vector equation. So Cartesian equation, vector equation, nice and easy to use. We'll look at a final example. Okay, in this example, we're looking at the idea of an intersection between a vector line and a sphere in Cartesian form. So first of all, if we look at that vector r as 2ti tj and minus 2tk, we can think about that in parametric form as x is equal to 2t, y is equal to t, and z is equal to -2t. Now, if we substitute these into the sphere's equation, x squared plus y squared plus z squared is equal to 9, we end up with 2t all squared, t all squared, and -2t all squared is equal to 9. We get 4t squared plus t squared plus 4t squared is equal to 9. That gives us 9t squared is equal to 9, and therefore t squared is equal to 1. That means t will be equal to plus or minus 1. That's our solution for the t values. The actual intersection point will be P as we sub into 2t, x equals 2t, y equals t, and z equals -2t. When we sub 1 in, we get 2, 1, and -2. Or if we sub -2 in, we get -2, -1, 2. So these 2 points are the intersection between the sphere and the line R. Okay, that concludes the lesson on equations of a sphere in Cartesian and vector form.